I just printed a simple string which says hello world, right? But what if I want to display something which keeps on changing based upon what my program is doing? Sometimes I want to say hello world, good morning. Sometimes I want to say hello world, good evening. How would that change? It would change based on the time of the day it is. So what I can do is I can check what the time of the day it is at that particular place, and then based on that I want to show the message to the user. Now how is that possible if I don't have the option to change what I am displaying? We do have an option to change what we are displaying just by making sure that we are not hard coding things. So by hard coding means that I actually put the exact value over here. I coded it from my own hand, right? So that's hard coding. I don't want to do that. I want to say something like greeting. Okay. But now if I just write greeting, it is giving me an error. So how do I make sure that this error is gone and I actually can change the greeting based on different times? So that gets me to the concept of variables. So now there are two things, okay? Let me roll back my changes, save this, and create a new class called variables. Now over here, again, I would write public static void main brackets, string args, square brackets, curly braces, and then within this, I want to do a sysout, and I would say variable lesson, right? I would save this and I would try to run this. So let's just press on run. Run as Java application, and it says variable lesson. Okay, so now this is all good. But again, I said, right, that I don't want this, I want something else. So for that, we can create a variable which would be called a greeting, and we can assign something like hello world. Hello world, good morning. And I want this greeting to be shown not as a string but as a variable. Okay. Now I've been talking about variable, but what exactly is variable? Variable is just a name which is storing our data, and we can keep changing our data and still call that using its name and still have the changed data being used by the program. Now what about all these other words? Public, class, public static void, system out, println, main, string, args, all these are also words, right? Why they aren't variables? They're not variables just because Java already knows its meaning. So Java will not allow you to use these words as another name for something else. So these words are known as keywords. So you have all the words which Java understands are keywords. And now you have variables which Java does not understand, and we have to define what it is, and variables cannot be keywords. So if I just put over here public, okay, can you see how different it is looking just because it is a keyword and we cannot use that? So I can just put something else which Java does not understand. But here again, you know, there is a squiggly mark over here, and it says that greeting cannot be resolved to a variable. Why? Why can't greeting be resolved to a variable? Because Java is a statically typed language. Statically typed means that Java wants to know from before what is going to be the type of greeting. Would greeting have a number? Would greeting have a string? Would greeting have just a character? Or would greeting have some other value like a fraction or something? So we have to actually tell the Java that greeting is actually a string, and now that error goes away, and we are able to simply save this program and run this over here, and now it says hello world, good morning. Now as I said that this variable can be changed, so now if I just write greeting equal to, instead of saying hello world, good morning, this would say hello world, good evening. And I save it, I run this. As you can see here, it says hello world, good evening. Why? Because greeting is now changed to hello world, good evening from the hello world, good morning. And the first time we declare greeting, we need to tell Java that, this is a type of string. But from the next time, we can simply use the name as over here. Again, here we did not write string or something, right? We simply use greeting. So this is how you can create variables. Now, as I said, that variables can have different types. So that gets us to understanding what are the different data types. What are the types of the different variables which we can have? So it is divided into two parts. One is the primitive data types, which would be simple numbers, numeric types, or simple non-numeric types. So we could have integers, or we could have numbers with a decimal point. So those are known as float. Or we could have non-numeric types like characters, or characters which are simply, one character of an English alphabet. Or we could have something like a Boolean, which means that it would either be true or be false. Okay, so something which has only two values, true or false, 0 or 1, that is a Boolean. A character can have all those values which are available in the English character plus all the special characters on the keyboard, all of that, right? And floating numbers, again, decimal point with a lot of digits after the decimal point and before the decimal point, integer again, from the smallest number to the biggest number, positive and negative both will be present in the integer type. Now, there are some non-primitive data types, which I already told you about, like, for example, arrays. You also know that there are some things known as classes, which we are going to see later on. Then there are some things known as interface, which we again are going to see later on. So we also saw about keywords. Now we come to the identifier rules. What do I mean by identifier rules? Identifier is what we call as variables. So both are the names of the same thing. This is a variable or this is an identifier. And we have certain rules of naming identifiers. We cannot simply name them anything which we want. One rule, as I already told you, is that it cannot be the same word as another keyword. Another rule is that the first character of any identifier must be either a letter or an underscore or a dollar sign. So if I have this letter meaning G, which is at the beginning, then we are fine. Or we can begin it like this with an underscore, and simply, I can copy that over here, and it will not be an issue. Or it could start with a dollar sign as well, right here. But what are the other things which is not allowed? Like spaces are not allowed. If I just write like this, here, can you see an error is coming? So that is not allowed. And the identifier beginning with any number, that again is not allowed, as you can see over here. And it beginning with any other character other than the underscore and dollar sign, again, it's giving me error. So all of these things you should take care of. You should not be bewildered that, why my error is coming over here. Remember that it can only begin with letter, underscore, or dollar sign, and it cannot have any spaces. Also, that identifiers are case sensitive. So like, for example, I type greeting over here, but here I actually write greeting, and here again, I actually write greeting with a capital G. So here, as you can see, these red lines are coming. Why? Because it says greeting cannot be resolved to a variable, but I just defined it, right? No, I did not define it. I defined the greeting with a small g, so it is case sensitive. And that's it. Some small simple rules to know. Another thing which I want to just tell you is the use of final keyword. So final is another keyword in Java. What it says is that this greeting is actually final. You cannot change this greeting. So as you can see, as soon as I added final, here a red line is coming, and it says the final local variable greeting cannot be assigned. It must be blank and not using a compound assignment, meaning that you cannot reassign something else to greeting. We have to use the same one. So whenever you are actually working with something which you do not want to change, for example, let's say I want to initially declare the value of pi. Okay, pi is what? 3.14. Okay, I want to use this everywhere. Now I don't want anybody to change it to 3.1416 or 3 like any other number, right? I want this to be exact same thing. So I can simply define pi to be final. So let me just remove final from greeting, add a final to pi, and that's it. But here again, some error is coming. Why? Because we have not defined the variable type. So greeting was string. What is pi? If we see over here, pi can be one of any of these data types, right? So can it be integer? No, but it has a decimal point. So it has to be float. So I'll just type float over here, and those errors will go away, and this is going to be our pi value. Another way to actually write this is double. So double again means float, and here, as you can see, again, any error goes away. Here it just says that the value of this local variable is not used. So let's now use it just to print that, and let's run this. So we'll save and we will run this. Okay, so 3.14 is the value of pi. Now there's this yellow line under greeting again, just to warn you that you have defined something but you have not used it, so just make sure that everything is correct or not. So this is how. Now if I would try to change this to something else, then it just would say the same thing, right? Final local variable cannot be assigned. So this is how we would use final variables as well. Now we saw float, we saw double. Let's create an integer. So I could create an int number, and I could just assign, some random number 5, and I could simply use this number to print that over here. Let me just comment out. If I want to comment out a number of lines, I can simply take all these lines over here, and I can simply press Control +/ on my keyboard, and here can you see that all of those lines are commented. So let me just comment this line as well. Now we simply have our number, and which is present over here, and this is where I'm printing this out. I just save this, I run this, and here we see 5. What about Boolean? I told you, right, that there's something known as Boolean. So I will say Boolean, and we generally name it as is true or is false. So let me just assign again, true to Boolean. Now true, as you can see, it looks something like a keyword in terms of formatting, right? And it is indeed a keyword. So I did not actually have to put inverted commas over here, because then it will become a string to true. But we do not want a string true. We actually want to say that is true has a value of true. So if I just print that, let's save this, let's print it. Now we have the value of true. If it becomes false, then it will have a value of false. So we would use Booleans a lot as well. Again, if we simply have a character, an English character, so let's just write a char a equal to, and then a character is put within inverted commas, and I will just put it as D, and then let's print out a, and let's run this. So the value of the character a is D. Now that sounds something strange, right? Value of character a is D. The only thing is that a is the variable and D is actually the character constant which we have assigned to a. So if we print a, we actually get the value which is assigned to a, which is D. So I hope you are clear about all the variable namings and how to add the types of variables beforehand and then simply use it by the name. So let's look into some more details. We have primitive data types, which each of those have a type name. Obviously, we used int, we used float, we used double, we used Boolean and char, right? So there is again, there is long, which is actually large integer. There is short, which is actually a small integer. And then there is byte, which has only 8 bits assigned to it. So 8 bits is assigned for a byte in the memory. For a short integer, 16 bits are assigned. For a normal integer, 32 bits are assigned, meaning 4 bytes. For a long integer, 64 bits are assigned, meaning 8 bytes. For a floating integer, which has a floating point, meaning a decimal point, for them, we assign 32 bits or 4 bytes. And again, for double, we have 64 bits, which is 8 bytes. For a character, we have only 2 bytes. And for a Boolean, which is only true or false, we have only 1 bit, okay? Only 1 bit, which will either be 0 or 1, will determine whether the Boolean is true or false. 0 is false, 1 is true, okay? So the range, again, true or false. Character range, for 2 bytes, how much would be the range? So character always is a positive number. And when I say number, you would be surprised, right? Because character is a character, it is not a number. When I actually would write a character A, that is converted to an ASCII value of a character, and that is used by the compiler to display which character is meant by that user. So if you check about ASCII on, let's say, Wikipedia, it would say that ASCII is American Standard Code for Information Interchange, short form, and it actually encodes characters. So if you just come down, you would realize that each of the characters actually have a value associated with it. So your capital A would have a value of 65, your capital B would have a value of 66, your small a would have a value of 97, and your small z would have a value of 122. You also have different values associated with different character types, even if they are digits or they are special symbols. So here I can just write 1 over here and save it and run it, and then you will realize it is 1, but it is actually the character 1 and not the number 1. So if I just write char b equal to 2, and if I just try to do a plus b, and plus is actually the plus operator. If we would have given numbers, then it would have given 1 plus 2 equal to 3, right? But then these are characters, so it would not be giving 1 plus 2 equal to 3. Let's see what it gives us. Oh, it gives us 99. That's why I say that they are not numbers, they are characters. And why did it give us 99? Because if you see, the ASCII value of 1 is 49 and the ASCII value of 2 is 50. So it did 49 plus 50 and displayed 99 to you. So did you understand that I was actually speaking the truth, that it is converted into ASCII characters, and that's how we have the character encoding for our programs. So now, since we have this encoding, it obviously is a positive number. So with 2 bytes, how much number can you get? You can get from 0 to, can you guess? 2 raised to 16. 2 raised to 16, because 16 bits are there, and we will have 0 to 2 raised to 16 minus 1, because 0 is 0, right? So it can't be 2 raised to 16. It has to be 1 less than 16, because we are using 0 indexing, right? So we start from 0. We actually don't start from 1. So 0 to 2 raised to 16 minus 1. Again, for let's say integer has 32 bits. Now we use something known as 2's complement to store integers. 2's complement is just a way to store positive and negative integers. So negative integers are having 2's complement and positive integers are just their values. So in 2's complement, we can go from the positive side 0 to 2 raised to 31 minus 1, because 1 bit is stored for the sign bit, okay? And then in the negative side, we can simply go to minus 2 raised to 31. So this is how the ranges work. You can check all the other ranges as well. We saw the types, the size, and the ranges. We saw, how we could declare a variable, how we could initialize a variable to a particular value. So what we saw over here is actually this part is declaring the variable, and this part is actually initializing it to this value. So we could actually have, taken this out over here, and we could have done just like this. And this is the declaration part in which we are declaring the variable. What is the meaning of declaring the variable? We declare the variable means that we are assigning memory to the variable. Assign memory to the variable, okay? And here we are actually initializing the variable. Initializing means giving an initial value to the variable, okay? Initializing the variable. So that's it. In case you are wondering why this is red, this is actually doing some spell checking. I don't want that, so let's just remove that. This is how we would initialize the variable, and then we can simply use the variable anywhere. Now, since we saw about all these types and their ranges, but let me tell you, most of the Java programmers would not be using these primitive types. Generally, like if I would have done it, I would have used something like this. Integer num equal to 5. Okay, and if I just print num over here and run it, this says 5, and this again works like an integer. Now you might be thinking this is just another name for it, but actually if I press on control and if I click on this particular small int, then nothing happens. I keep doing that. But if I press control and click on this, I actually go to the integer class. So I realize that Java engineers, somebody known as Joseph Darcy, has actually written this class known as integer, which would extend other classes. So we are going to talk all of that. But then what I want to say is that this is actually not primitive data type. This is known as a box, which encompasses my integers which are primitive. Okay, so int is primitive, but integer is a class which acts as a box around it, and what that helps me with is some common procedures which I would want to do that on integers. So let's say if I write number and I do a dot, then nothing happens. But if I just write num and I do a dot, then I have all these options with me, and all these options are actually all these methods. So like we have the main method, like we have this println method which is actually helping us to print things, we can have different other methods which Java provides us, the Java class integer provides us, and that actually helps us to do various other things, like we can compare to another integer, we can convert it to a double, we could convert it to a float. Let's say if I just write this num dot float value, let me just cut that and paste it over here. Let me run this. And you will realize that earlier I just put print 5, but now it is 5.0. Why? Because it just got converted into a float. So this is a good thing, right? So because it may be that I want to do so many other things with an integer. So what we do, we have a box around it. We have a class defined by Java, which helps us to have all the most common things which we want to do again and again on a particular number, which we don't want to actually type out ourselves. The common things which we don't want to type out ourselves, Java engineers have done that for us, and this is known as boxing. Okay, similarly for character, you have the character class. So you could have something like this, character C equal to A. You could have the float class, which is actually helping you with all the other floating points. You could have a double class. So now you would have realized that actually the words are a little different, but again, they all start with a capital letter. And even when I created a new class with the name of variables or with the name of first program, you would have realized that it always has a capital first letter. Okay, so remember, to name classes, we need to have capital letters. So capital letter used for beginning of class names. Okay. So we saw something known as auto boxing. Auto boxing is just a way in which wrapper classes are there on each of these primitive types. And then the opposite would be unboxing. So you actually don't want any box. You would want to unbox it and just use the primitive types. That is known as unboxing. You can even go to the Java documentation, which is easily available on docs.oracle.com. You can simply do a Google search and you can read upon auto boxing and unboxing as well. So here, as it just takes a simplistic example of a character CH, and it actually helps you realize that how much you can do with boxing and unboxing. So here it had an integer I, and it just called the absolute value method on I, and it actually converted into the primitive int, and it would simply do a system.out.println. So all the other things which might be confusing you right now, we are going to cover all of that, so don't worry. But the whole point is for you to understand that we can change it from the primitive to the class just by making sure that we are declaring it using the class name, or you can change it from the class to the primitive data type. Now, what are some best practices in doing whatever we have done? So for example, you want to name your variables, you should always try to use the camel case. So this is camel, okay, and this is the kind of case we want to use, based on his humps. We want to always capitalize the next word's initial character, okay. So that's the way we would name variables always in Java. We have to give proper and meaningful names, not like A or C, which I was giving. It has to be meaningful, what it does. It cannot be like very, very long or too short to not be able to understand. So it cannot be encoded something like QRFW, because I don't know what is the meaning of QRFW. And semicolons, always remember to add semicolons. The next thing which we will discuss is about operators. One operator which we just saw was the plus operator, which would do an addition. Similarly, we have so many other operators in Java. We have unary operators which work on only one operand. Operand means that number or that variable or that data which we want to work on with that operator. So if we just have one data on which that variable works, that is a unary operator. If an operator really requires two data or two variables, then that is a binary operator, which may be arithmetic operators, relational, logical, or assignment operators. You would also have operators which actually work with three data. That is known as ternary operator. And then we will understand what is the meaning of precedence and associativity of different operators. And then finally, we will look at a specific type of operator known as instance of operator. Now in this Java short course folder, I'm creating a new Java class file with operators title, and here let's talk about the various operators. So first let's add the public static void main string args, and here let's create two integers. Int a is equal to 4 and int b equal to 6. Now we were talking about unary operators, right? So unary operator like minus will act on a particular operand, which is just one operand, and that's something which will give us the negated value of a. So if I just do a sysout of minus a, and let's save it and print it, run as Java application. Oh, so there was an error over here. I forgot the void. So let's try to run this now. As you can see, a got negated and now its value became minus 4. Similarly, you could have a plus operator, which again, it's not going to really do any change. Another thing is the logical not operator. This is generally something which we use with a boolean. So let's create a boolean is true equal to true. And now what we want to do is we want to find out its value. So if I just save this and print it, this will become true. But what if I actually add an exclamation mark before? What this is going to do is it's actually going to change the logic of is true. So if it was true, now it will become false. So let's save this and run this. So now as you can see, this has become false. If it was actually false, then if I run this, now it is becoming true. So this is the logical not operator. Another unary operator, which is something which is very important, is the increment operator. So if we have a, and then if I just say plus plus, what does this mean? What this means is that a will now become 5. Okay, so this can be after a or it can be plus a. Let me just show you what happens if I just put plus plus a. If I run this, now you can see a was 4, but now it became 5. So if I do it after a, again, a will become 5. But then when I print this, right now I'm getting 4. But oh no, how come this is possible? If I just do a sysout again, and if I just print a again, and if I run this, then if you will see that now it is 5. So the first statement actually resulted in 4 and the second statement resulted in 5. Why is that so? When I said that this plus plus is going to increment the value of a, it is actually doing that because the next time what is there in a, it is 5. But here my printing is happening with the original value of a. Why is that so? So that's the difference between the pre-increment operator and the post-increment operator. So pre-increment is plus plus and post-increment is plus plus, but then it is a plus plus and here it is plus plus a. Okay, so this is the difference between pre-increment and post-increment. And what pre-increment does is that it will increment the value of a and then return. So it increments and then returns. Okay, but what about post-increment? Post-increment actually first returns and then increments. It first returns and then increments. Okay, this is the difference. So here what is happening is that first it is returning the value of a, and then it is incrementing to the next value of a. Then there are binary operators. So we already saw what plus would do. If we do an a plus b, then you will realize that if I just comment this out, you will see that a plus b is giving us 10 because that is 6 plus 4. Similarly, we could do an a minus b, and that would give us minus 2 because this is 4 minus 6. Or if we did a multiplication operator, again, we would have the proper multiplication answer. Or if we did a division operator, then we would simply, have the division quotient available with us. What if we want to find the remainder? For finding the remainder, we use the modulo operator, and that is the percentage mark. And this is actually going to give us the remainder. So 4 divided by 6 is 0 quotient and remainder is 4. So that's the arithmetic operator part of it. We also have relational operators. So we can just write something like a less than b, and when I run this, it will say true. Why? Because a is indeed less than b. Similarly, if I write a greater than b, this will be false. We also have less than equal to b, and this will also be true just because, a is actually less than equal to b. Similarly, we have a greater than equal to b, or we can have simply like a equal to b, because that is going to give us false because, 4 is not equal to 6. And what about not equal to? That is exclamation equal to mark, and this is going to give us true because a is indeed not equal to b. Now, all these are conditional operators which are giving us true and false values. What if we want to actually find out a combination of all these different values? So, for example, I want to see if a is not equal to b and if is true or false. Okay, so a is not equal to b, and somehow I want to find whether is true equals to true or not. Okay, but then here again some error is coming because I cannot just write and. I will have to write ampersand ampersand, and this is going to give me my result. So now it says false. Why? A is not equal to b, that's right, but is true is equal to true? No, it is equal to false, so that's why it was giving us false. What if I just write this thing? So now it's giving me true. So what AND operator does is that only if both of them are true, it will write true. In any other case, it will write false. What if we want a case that, no, I don't want to be so strict. What if I just want, at least even if one of them is true or both of them are true, then also it should write true only. For that, we have a logical NOT operator, which when I run this, this is going to say true because just because, both of them are true. What if I just change one of them to be false? Still it is giving true. Why? Because at least A is not equal to B, right? So we are fine with that. So these two are logical operators, and or. And then when we come to talk about binary operators, we have assignment operators. So this int A equal to 4, this equal to operator is actually an assignment operator. So what is happening is that 4 is actually assigned to the name A, okay? 6 is actually assigned to the name B. Now, what if I do, let's say, A equal to 6? Obviously, 6 is getting assigned to A, and that's what we are going to print now. Let's see. So now A is equal to 6. That's fine. What if I do A plus equal to 6? What this actually means is that A equal to A plus 6. Okay, this is a compound assignment operator. When we run this, what happens is that the initial 4 is added to 6, and now we have an answer of 10. Okay, so this is how compound assignment works. This could also work with a minus. So here it is actually doing a subtraction to 6. Again, it would work with multiplication, division, and modulo, similarly the way we saw earlier. Okay, so I'll just keep it like this. And finally, we were talking about a ternary operator. What is the meaning of ternary operator? It works with 3 operands, right? So that has a skeleton. So the skeleton is a question mark and a colon. So anything before the question mark will be any condition which we want to check. If the condition is true, then the thing after the question mark should be executed. Otherwise, the next thing after the colon is executed. So this is the ternary operator. So again, if I just take this print statement over here. I just check if A is equal to B or not. If it is, then I want to just print equal, or I want to print not equal. Okay, so let's save this and let's print it. So it says not equal. Why? Because A is actually not equal to B, so it is false. So false means the next part. If it was true, meaning if I just do A not equal to B, meaning if I actually change the values of A or B, so if I just make A equal to 6, and if I try to run this now, so now it will say equal, because now A is actually equal to B, so that's why it will say equal. Okay, so that's one way in which you can use ternary operator, and there can be many other ways in which you just want to add a condition over here, execute this part of it. If you actually want to execute multiple lines, then you would simply write a block over here. Okay, so whatever I've shown in system.out.println, all of this need not be within system.out.println. It can be even outside. Okay, so if I can just write something like string equality check, and now I want to just print this equality check, then if I run this again, it would be not equal, just because A is not equal to B. So this is how you can do within Java, or you can actually execute a number of lines of code in this part and in this part as well. Now when we talk about operators, it may be that sometimes some operators take more importance than the other operators. For example, if I do A plus B into A, then what is going to be the answer? It's going to be 28. Why? Because first B into A is actually implemented. So first we do 6 into 4, which is 24, and then 4 is added to it. And it's not that 4 plus 6, 10 into 4, which is 40. So why is this so? Because multiplication has a precedence over plus, and that's where comes the concept of precedence and associativity. So let's say A plus B minus A, okay, and if we run this, it's going to be 6, okay, and let's do minus A plus B plus A. If I run this again, it's 6. The reason for that is plus and minus both are the same level, so however I use it, it doesn't matter. But then it would matter whether it is coming from the left to right or right to left. Okay, so now if I just add a C and make it 3, and if I just write C over here and let's save this, print this, then what is happening is that first A and B are added and then C is subtracted from that. So what would we say? We would say that arithmetic operators have an associativity of left to right. So how would we know which operator has high precedence and which types of operators have left to right or right to left associativity? I'm going to provide you with a table which is going to make sure that you know that unary operators have the highest precedence. So obviously if I do plus plus A over here like this, and if I run this, what is happening is that A is first getting incremented and then it is getting added to B and then C is subtracted from there. So unary operators are definitely the ones which have highest precedence. Then comes arithmetic operators, and then you have your relational operators like less than equal to or greater than or equal to, and then you would have your logical operators like and or, right? So that precedence table and what is the associativity, that is something which I'm going to provide you with. And lastly, if we just want to check, the type of a particular variable. So let's say I just want to check the type of, C. So, oops, that's not the way. We really have to say if C is an instance of int or not. Okay. But here we should have a class, and instance of would take this class and check whether C is an instance of integer or not. So if I run this, it is saying true because C is actually instance of integer. What if I say string? Is C an instance of string? So here it says incompatible conditional operand types, integer and string. What if I just want to check is it an integer instance of float? Again, it says incompatible conditional operands. So instance of can be used for this task. Now, what if a variable is of a particular data type, but we want to change it to another data type, right? So I already told you about unboxing, right? So what if I want to change this class integer type C in the primitive data type int type C? So if I just add the int with the round braces before C, this is actually going to convert C into the integer type over here. It is going to convert C into the primitive integer type. If I could also have done it, let's say double, and then if I would have printed it, here it comes 3.0. So that's how we could have type conversion. We are actually converting the type of, let's say, primitive integer A to double. Okay, so again, we have this type conversion, but also it is possible to have an automatic conversion. So for example, A is what? 4. Okay, if I do A into 1.5, okay, now if I print this, this is not 6 because 4 into 1.5 is 6, but it is not 6, it is 6.0. Why is that so? Because 1.5 is a floating point number, it's a double, okay, and that's why A got automatically converted to this whole thing just because of another variable of a higher type, which is double, and that's how integer got converted into double. So again, how these conversions are taken. So if you have byte, it can be converted to short. If you have short, it would be converted to int. If you have a character, and that could also be converted to int. So int will not get converted to a character. Character can be converted to an int. If I just write A into a character C, and if I just print this, then this would say 396. So why is this not converting 396 to the ASCII equivalent of 396? Just because int will not be converted to character, character will be converted to int. Okay, similarly, int will be converted to long and not long to int. Similarly, int will be converted to float, int will be converted to double. Long will be converted to double and float would be converted to double. Similarly, long would be converted to float and not vice versa. Int would be converted to double and not vice versa. So I hope you understand, the smaller one gets converted to the bigger type of data. So there are two ways, either automatic conversion or you yourself typecast it. So what I did earlier was actually typecasting. So this was typecasting.